Everyone, and welcome back to another exciting day in mathematics. Whoop, whoop. Warm-up number 71 is on the screen. Hopefully that shouldn't take you more than about 4 or 5 minutes. And then from there, get a Cornell note ready so that we can move on today. And just so that you know, so that you're not so completely surprised, we're going to move on to word problems. How about them apples? Let's go, let's go. So today's going to be all about applications and see how we do with all that. And yeah, copy that and go. What you get for number 1 to complete that? Dylan plus what? Which is 0.25 or 1/4. That is correct. And my factors, 1 over 2 squared, so that means x plus 1 over 2 squared. Hands if you got that? Yeah? Okay. Number 2, Mr. Q, all right, 6i, all right, so far so good. Addition, 3, JP, what you get? 13 plus 2i, that is correct. How about subtraction? What did you get for subtraction? Jessica? That is correct, negative 17. How about multiplication? Frida? Negative what? 31. Plus 13i. That is correct. And division, pass someone. Close. So remember, the only thing that we need to change there. Negative? Yes, negative 17. Very good, thank you. Yeah, division, we got I minus 2 divided by I plus 15. Fits in there once. 1 times I is I, 1 times 15 is 15. We subtract, which means we distribute that one here and here. This cancels. We're left with negative 17 as a remainder. So therefore, 1 is here, negative 17 there, and our divisor down here. All right, number 4a, inverse. Julian. That is correct. Check your work, please. And number 4b, What do you say that? What'd you get? 5x plus 20 over 2 equals f inverse of x. That is correct. However, this is correct, but we need to make it look like that in case they ask us to graph it. Is that correct? So 5 divided by 2 is the same as 5 halves x, and 20 divided by 2 is 10, and all that f inverse of x. All right? Just remember it needs to be in slope-intercept form for graphing purposes. All right, copy the agenda for today. Here we go. Warm-up number 71, Quadratic Equations. Tonight's home play, only 2 pages, 121 and 122. But as I mentioned earlier, today we start with applications. Let's go. Your favorite throughout your math career, right? All the work problems. Let's go. Oh, yeah, we got this. All right. And your weekend went pretty good? Your home plate? Yeah? So you never the home plate for the weekend? How'd you do with your home plate, Valente, over the weekend? Yeah. A little curveball, yeah. You did well, yeah. Okay, good. All right, copy the objective for today. We're going to get started right away. Get a Cornell note. Our objective for today is solve and graph quadratic equations by completing the square and quadratic formula. But today we go into applications. We started with quadratic equations semester 1, and we said that they are two variable equations where the highest degree is 2. We did examples, done examples. From there we moved on to solving it 3 ways last semester: by graphing, square roots, and by factoring. You did some of that on the home play last week. And then from there we moved on to completing the square. We went through the entire process. We did that in class. From there we did quadratic formula. So, tell your neighbor the quadratic formula. See if they remember what the quadratic formula is. All right. Let's see, Diego Rosas, quadratic formula. X equals minus b plus minus square root b squared minus 4ac over 2a. X equals minus b plus minus square root b squared minus 4ac over 2a. X equals minus b plus minus square root b squared minus 4ac over 2a. And yeah, we hammered that one like, oh my goodness, we repeated it like close to 20 times. And for those of you that visited my YouTube channel, you see my avatar is like a Jedi master with numbers, right? And you're like, it's a hacker, Mr. King. No, it's not. It's a Jedi master with numbers. And in the background is a quadratic formula in flames. Let's go. Or neon colors. All right. So with that said, from there we went to solving quadratic equations with the quadratic formula. Yes. And we did some of those. And then we got to Friday and we had a pop party for both. Right? Okay. So this is where I want to get to today. Today we're going to be looking at word problems and some common formulas used to solve certain situations in mathematics, which are the most common used equations in quadratics. Copy this, please. In blue, on the left side, distance fallen in feet at t time in seconds, and you're going to write d of t equals 16t squared. And on the right side with green, you're going to write height in feet at time t in seconds, where h of o is the initial height, and then you copy h of t equals h of 0 minus 16t squared. Copy that, please. Do me a favor, in red, underline on the first formula where it says time t. And then in the formula, here where the t squared is at, just write the t in red. So like that, we know that that's referring to time. Okay? And the reason I want you to underline that one, because on the second formula, also time, t in red, and we substitute this t in red right here to remember that that is time, t for time. Okay. All right, so let's go over the first formula. It says distance fallen in feet at time t. So we know that t is for time. So tell your neighbor what the d stands for, please. What does the d stand for? Yeah, distance. Exactly. So distance, that's why we see the d right there. Okay. Let's go to the second formula. The second formula says height in feet. However, it also says where h of o is initial height. So this part, box it in green, that's the initial height. So just label this one in green. So like that, whenever we get to a problem and I use green, that means that we're going to substitute for that. which leaves us with the other one that says height in feet, which is this one. And this one I'm going to label in blue because it kind of mimics what? A distance, But now instead of D of T, they have it as what? H of T. Okay? Okay. How we doing? Good? All right. So we talked about D. We talked about the H's. We talked about T. What's the only thing we haven't talked about? The 16. So let me elaborate on 16 just so that hopefully it makes sense. I'm not going to get too deep into it. It's more of a science question for your science and your teachers to go a little bit deeper in this. Maybe they already did. So here we go. So imagine, well, especially those of you who are watching on video, imagine I spin this basketball on my finger. Yeah? So here we go. What keeps it in the center? Think about it. What keeps the ball in the center? One of them is gravity. Very good. The second one is what? The rotation of the ball. There's a momentum going, right? So the rotation keeps it going towards the center. However, gravity is trying to pull it where? Down. So there's two forces going on. The Earth works the same way. As the Earth turns, there's one force. The second force is what? Gravity pulling it down. That's why, guys, I don't know if you noticed, that when you go and trip and fall on the floor, you don't fly off the Earth, right? No, we stay on the floor because it's pulling you what? Towards the center of the rotation. Does that make sense? However, that's how many forces? Two. Today, we're only going to be looking at problems about things falling down. Not involve rotation or anything like just falling down in what? Only one direction. How many forces? One. Now, scientists came up with a formula, and they figured that those two forces, one because of this and one because of gravity, gave us a number that was close to 32 point something. How many forces? Two. But today we're only looking at what? So what do I do with the 32? If I'm only going to focus on one, divided by, and that gives us 16. Does that make sense? Yeah? That's as deep I'm going to go, but that's what it is. All right? And aside, I mean, I know some of you are like, well, Mr. Q, it stays on your finger because you got skills. That's right! Got skills. That out. That out, little boy. All right, copy this, please. Example number 3. Don't copy the bolded text. Just copy the bottom one where it says, if you drop a water balloon, how long does it take to fall 4 feet? Copy that. The other ones are just instructions of what we're going to do right now. Once again, the situation reads, if you drop a water balloon, how long does it take to fall 4 feet? So I know some of you are artistically challenged, so we need to do a sketch of the situation. So just follow my lead, especially those of you, like I said, that are artistically challenged. It's okay, you know. Hugs from here to you. Here it goes. Let's go. Some of you are like, I messed up already. Here it goes. All right. Pretty good, yes? Now, over here. Bam. Pretty good, yeah? All right. So, Let's label our problem. Let's see what it says. It says, if you drop a water balloon, how long does it take to fall 4 feet? So, underline where it says 4 feet. What do I label that? Height, or I'm going to label it D for distance for right now. Okay? In red, how long? What does that mean, guys? What do I label that? T for time. That is correct. All right. So that means that this height from here to here, which is our distance, how high is that? 4 feet. Okay. So, think about it. How many pieces of information did we get from the problem? Only what? 2. Look at your formulas. Which formula shall we use for this situation? Tell your neighbor, please. Which formula shall we use? All right. Juan, which formula? Go. D of t, very good, equals to 16 t squared. All right. So we know that we need to figure out t, because that's what they're asking us for. But what else do I substitute into the formula? Instead of this, we substitute what? 4 equal to 16 t squared. So, to solve that quadratic equation, we already know 5 methods: graphing, square roots, factoring, completing the square, and quadratic formula. Diego, Romo, which method do you want me to use to solve this one? Roots, okay. Square roots, all right. So line down the equal sign. We need to leave the t squared by itself. So 16 is multiplying, so I need to divide by 16, divide by 16. We're left with 4 over 16 equals t squared. How do I cancel that squared, everyone? Square root, square root. Therefore, I'm left with, what is square root of 4? 2. What is square root of 16? 4. And this is plus minus, and all that equal to t. However, look up, please. This I cannot use. Talk to your neighbor, let them know why I cannot use that negative. Why can't I use that negative? All right, good conversations. What do you think, Delilah? Why can't we use the negative? I'm sorry? No, the negative, not the fraction, the negative. Caleb, what do you think? Right, we can't use it, but why? Let's look at the problem. If you drop a water balloon, how long does it take to fall 4 feet? You come go negative time. You're not Superman. Superman's the only one that goes, what, against the clock or whatever? According to the movies, right? So that's why we cannot use time. So keep that in mind as we go through word problems, guys. Specifically, time and distance, we cannot use the negative number. So it's always going to be positive. However, can we simplify this a little bit more? Yes. It's 1/2 equals t, which means 1/2 what? Second. All right. So from now on, any word problem we need to answer with a sentence. Let me read the problem. It says, if you drop a water balloon, how long does it take to fall 4 feet? Ivan, go. Tell me what to write. Yes? It takes half a second for the water balloon to fall 4 feet. Damn. 10Q. Pretty simple, yes? From 1 to 5, how comfortable are you with these so far? Yeah? 5 4 is 5 4? Yes? Okay. All right, go to the next one. On this next one, don't copy the text. I want you to copy the sketch. Copy that sketch, please. As you're copying that sketch, let me read the situation. It says, the rooftop of a 5-story building is 50 feet above the ground. How long does it take the water balloon drop from the rooftop to pass by the 3rd story window at 24 feet? Okay, copy that and we'll get started. All right, so So 5-story building, 50 feet above the ground. How long does it take the water balloon to be dropped from the rooftop? Okay, so let's draw a water balloon. I'm going to draw it on this side over here. There it is, and it's going to drop in that direction. All right. So let's see what they give us here in the building. They give us a height. We know that's a distance. I'm going to just label it for right now, distance, or H for height. Okay. What else do you guys notice? 24, is that correct? What can we label 24? Also a distance and also a height. Okay. So far we got two things right there, and then it says on the question, how long does it take? What do I label that, guys? Time. There it is. So we got how much information? Three things now. We got time, a distance, and another distance. Look at your formulas and tell you never which formula are you going to use for that one. All right, so write it down. The second one, right? H of t equals H of 0 minus 16 t squared. Now let's see. What does H of 0 represent? The initial height, right? So what is the initial height of all this, guys? The 50. So this one, label it H of 0. Do that in green. I'm going to change that to green, H of 0. So that means here we're going to substitute the 50. I bring down the negative 16t squared. So that means, that leaves us that the other height, this one over here, is going to be our H of t, or our distance. So I'm going to substitute what? 24 on this one. And that leaves us with us trying to figure out t. So, Diego, Romo, what method do you want me to use to solve this? Square roots, okay. So line down the equal sign. We need to leave this by itself, so how do I get rid of that 50? Subtract 50, subtract 50. That leaves us with negative 26 equals negative 16t squared. The negative 16 is multiplying, so to get rid of it, I need to divide by negative 16. That leaves us with 26 over 16 equals t squared. Diego Rosas, last step. Square root, square root. We're left with, let's see, what is square root of 26? I don't know. I'm just going to leave it at square root of 26. What is the square root of 16? 4 plus minus and all that. Since it's a square root, I'm going to do approximately our time. Now, which one are we going to cross out of here? We're going to cross out the negative. So question, what is Square root of 26 over 4 in seconds. I don't know, unless we know what square root of 26 is. What's that? No. Tell your neighbor how to find the approximation of that one, please, without using a calculator. All right, Noel, between what two numbers is 26 found? Help them out, Lysandra. 25 and 36. That is correct, between those two. That means if I take the square root of 25, this is going to be approximately 5 point something. You're like, oh, right? So, subtract these. What is 26 minus 25? That's 1. Subtract these. What is 36 minus 25? That's 11. So, 1 divided by 11 does not fit. Does it fit into 10? No. Add another 0. Does it fit into 100? Yes. 9 times. 9 times 11, 99. I'll leave it at that. So it's 5.09. So this becomes 5.09 divided by 4 approximate seconds. So find me how many seconds that is. How many seconds that is. Yeah. 1.3 close, so it would be 1.27 seconds. That is the purpose of why we cannot leave these as square roots. You're like, that's why we did the warm-ups. Let's go. Statement. According to the situation, let me read this situation again. So from the rooftop, 5-story building, how long does it take the water balloon drop from the rooftop to pass by the third story window at 24 feet? So you neighbor a statement before I call on someone to help us out. What would be a statement for the end? Statement for the end. All right. So, statement. Diego Rosas. It takes the balloon 1.27 seconds to pass the third story window. 10Q. Thank you. Approximately. All right. From 1 to 5, I'll come through you with these. Yes? Let's make sure that we understand how to use the formulas. Let me go back to the first problem. Look up to the screen. Look up, please. I labeled my problem. Look at it. And how many pieces of information did I have? Only 2, time and distance. That's why I use the smallest formula. Let's go to this problem that we just did. I labeled my problem. How many information do I have? 1, 2, 3. In this case, 2 heights or 2 distances. That's why we use that formula. Any questions in regards to selecting your formula? No. From 1 to 5, I'll come to you with these. 5 fours, 5 fours, okay. All right, look at this one. And copy only this function really quick. We're going to go pretty quick just for the sake of time. Copy d of t equals 8/3 t squared. All right? So it reads, On the moon, the distance in feet of an object that falls in t seconds is modeled by this function. Suppose an astronaut on the moon drops a tool. So question, how long, that means they want us to figure out the time, does it take the tool to fall 4 feet? That's a distance. That's why they gave us a small formula. So all I have to do is substitute what? 4, and that is 8/3 t squared. And then if we use square roots, what do I multiply here to get rid of the 8/3? The reciprocal, right? So 3/8. We do that to both sides. So we end up with t squared. Of course, this becomes a 1. T squared equals 12/8. Diego, last step. Square root, square root. We end up with, check this out, what is square root of 12? Well, I'll just leave it at square root of 12. Square root of 8, still square root of 8, equals t. Now, in this case, it's like, wait a minute. Can we have square roots on the denominator? No, I'll tell you never how to get rid of that square root on the denominator. They should know by now. Briseida, go. Yeah, multiply top and bottom times square root of 8. That is correct. So this becomes square root of 64, because 8 times 8 is 64. And this is 8 times 12, that's 96. So square root of 96 over, what is square root of 64? 8. Okay, so now our new fraction is square root of 96 over 8, approximately. Now you're saying, wait a minute, still not completely clear, Mr. Q. What is square root of 96? Well, what is square root of 96? Between what two numbers? Between what two numbers is that found? 81 and 100. So that means it's going to be approximately 9 point something. Subtract, that's 15. Subtract, that's 19. So 15 divided by 19 does not fit. Add a 0. Fits in there 7 times. 63, we got 6, 13. That's 17. So I'll leave it at 9.7. Therefore, 9.7 divided by 8 is approximately how much time? That is 1.2 seconds. And we write our statement at the end. It takes a tool to fall 4 feet on the moon, 1.2 seconds. Yeah. All right, I think we got this, right? All right, your homework is going to also have these. Copy this rectangle, please. Example 3, Shazam Q. The rectangle being the height is 2x, the base is 3x. And they give us this information. The area of the rectangle is 60 centimeters squared. So we need to start with a formula just like the other ones. So you never the formula to find the area of a rectangle. The area of a rectangle. Area equals, everyone? Yes, base times height or length times width. I'm going to use base times height. So what is my base, everyone? 3x, yes, which is this one, times 2x, all that equal to the area. What is the area according to the information? 60, yes. So this becomes 60 equals 6x squared. What method do you guys want to use for this one? Square roots, okay. You sure you guys don't want to use the quadratic formula or something? No? Okay. Divide by 6. 10 equals x squared. Of course, square root. Square root of 10 equals x. Now, this is what I want you to do right here. Look up. Label this one exact. Because on the home plate, on some of the, I think one problem or two, they're going to ask you, give the exact amount. This is exact. However, when we do the extra step and get the decimal, that's what? Approximation. Approximation. Whenever we find the decimal. And the decimal, you know how to find that, right? Yes? So this is approximately 3 point something. This is 1. Subtract 7. So that is 1 divided by 7. Does not fit in there. And a 0. That's 1. 3. I'm sorry, 7. I'll just leave it at 3.1. So this is 3.1. And that's approximately. Now that's not in seconds. That is centimeters. X is 3.1 centimeters approximately. And of course you substitute in there, and that's going to give you what each side measures. All right, from 1 to 5, once again, applications, how we doing? Yep. 4, 4, 4, 5, okay. All right, and to, yeah. So, yeah, if it's exact, you still write x equals square root of 10 centimeters. All right, copy this one, please. We're still not done. Where you guys going? Example 4, imaginary numbers. Now we're getting really into the imaginary. We're going to be moving on tomorrow. So, yeah, put on your seatbelts, guys. Let's go. Copy this. 5i. And for home play, they're going to ask you to square them and simplify. So here we go. It says to square them. What does that mean? You put that in a parentheses, squared. Let's go through the process. That means 5i times 5i. All right, let's do numbers with numbers, variables times variables. What is 5 times 5? 25 times, what is I times I? I squared. Are we done? No. What do we substitute for I squared, everyone? Negative 1 times 25, so that gives us negative 25. Go! Let's go. One more. Here we go. Copy this one. I knew it. Negative I times square root of 2. And we're going to square it. All right, what does that mean? Negative I times square root of 2 times negative I times square root of 2. All right, here we go. What is negative I times negative I? I squared. What is I squared? Negative 1. Okay. Next. What is square root of 2 times square root of 2? Square root of 4. What is square root of 4? So negative 1 times 2, that's negative 2. Hold on the wrist. All right. From 1 to 5, how come are you with imaginary? Yeah, we got this, right? Okay, we'll stop right there. Once again, your home play on both pages is going to involve everything we saw today. So just put in the practice, please. I'll stop the video right here. And once again, if you guys see my basketball somewhere, tell them to bring it back, please. We miss it. Enjoy your home play. See you guys tomorrow. Bye. Yeah. Yeah.